Now let's put the past two concepts together and we're going to solve absolute value inequalities. And I have kind of labeled this page and then the next page by their symbols. So on this page, we're going to go over less than or equal to absolute value inequalities. And you're going to see that these behave similarly. And then when we go to the next video on the next page and we go to greater than or equal to, those will all behave similarly. So if we start with A, just a super basic one here. It says the absolute value of X is less than 3. So the absolute value means that we're talking about the distance from 0 must be less than 3. So I've put over here kind of what I just said, right? But this means that X must be less than 3 units away from 0. So less than 3 units would be everything right in here. So we're talking about that portion of my graph. Everywhere in there has an absolute value or a distance from 0 that is less than 3 units away. So we actually need to graph the solution set. That's where I started. So let's now express this answer in interval notation and solve also the inequality. So if I solved this portion over here, this graph kind of reads that X must be greater than -3, while this side over here is showing that X must be less than 3. Now there is kind of a condition with this, because if we just said X is greater than 3, it would keep shading all the way to infinity. If I just said X was less than 3, it would shave all the way here to -infinity. So if you say these two inequality symbols, it's really talking about this entire number line. So we're not talking about that entire number line. We're talking about just this section here. So we are talking about sections where X is greater than -3 and X is less than 3. Okay, this "and" is kind of a big key word here. And so we can express our "and" as a single inequality, and that would be -3, switch that symbol, is less than X, which is less than 3. So this is our inequality. Now to express this in interval notation, that's a little bit easier. We're talking parentheses, -3 to 3. Okay, so those were the 3 things we had to do. Solve the inequality, or the absolute value inequality. Here it is. Express your answer in interval notation. Here it is. And then graph. There that is. So let's follow the same pattern here. If I have the absolute value of X plus 5 is less than or equal to 17. Notice one of these inequalities looks exactly like this one here without those absolute values. So we would have the not even the absolute values. We would have X plus 5 is less than or equal to 17. That's my first one. Then for your second one, we would have still X plus 5. Notice here, they switched that symbol. So instead of it being less than or equal to, it's greater than or equal to. And instead of it being 3, it's -3. So this will be -17. So you're still building your 2 equations the way we did with absolute values. But because these aren't equals, you have to flip this symbol. So the first one looks exactly like this without it. The second one, you have your symbol flipped. Instead of it being positive, now it's negative. So let's solve. Subtract your 5 over, and we get X must be less than or equal to 12. And here we get that X, when we subtract over our 5 here, we get X must be greater than or equal to -22. So these are our inequalities individually. We can combine these to become negative 22. Flip that symbol, is less than or equal to x, and then this one's in the right order. X is less than or equal to 12. Okay, these mean the same thing. This is most of my answers, and then here they are kind of together. Okay, so now if I graph this, I'm going to use black. Going from negative infinity to infinity. And my two numbers here are negative 22 and 12. They're both or equals to. And there they are. So you can see this one is x is greater than or equal to negative 22, so above it, and x is less than 12, below it. And that's what these two have in common right there. These are our and statements. See, same thing. What do I have to do first before I break this up, though? We have to isolate this absolute value. So I have the absolute value plus 3 is less than 10. So move that 3 over. And we get the absolute value of 2x plus 5 is less than 7. So now that that absolute value is isolated, break this up. The first equation looks exactly like this without the bars. So we have 2x plus 5 is less than 7. My second equation is still 2x plus 5. This still comes out of your absolute values, but now we're going to flip this symbol and make this negative. And this is another and. So for this first one, we're going to subtract that 5 and then divide by 2. And we get that x is less than 1. Over here, we're going to subtract our 5 and then divide by 2 to get x is greater than 6. So I'm going to end up making my inequality symbol, but let's just graph this based off of these right here real quick. We've got negative infinity to infinity, and we're going from 6 to 1. Okay, at 6, we are talking about things that are greater than 6, and at 1, we're talking about things that are less than 1. So we are talking about everything in between here, right? Numbers that are less than 1, numbers that are greater than 6. They both don't have that bar underneath, so these will both get parentheses. So in interval notation, this is negative 6 to 1. Now, if we need to write this as an inequality, for the record, I am fine with this right here, but just in case my math lab wants this as a compound inequality, okay, these always need to be least to greatest. So we're going to start with negative 6. And so because negative 6 is coming first, I have to flip this symbol. And now this one's in the right order. And so there is this one inequality here representing these two right here. And if I back up just a little bit, we never wrote this one in interval notation. So if we write this in interval notation, this is bracket negative 22 to 12 with a bracket. Okay, so I don't feel like my flow was really good on that lecture here. So just to kind of reiterate, let's talk about C real quick. Here's what we're doing. Okay, first thing you need to do is make sure that absolute value is isolated, because so we had the absolute value plus 3, we had to subtract our 3 over to get this 7. Once you have that absolute value inequality broken up or isolated, now break it up to your 2. So the first one looks exactly like this without the bars. The second one, that 2x plus 5 came out of the bars. We flipped their symbol and we made this negative and we solved. Once we got to this right here, I can now graph. So I need a graph that shows that this is less than 1, which we have, and greater than -6, and we have. So it's talking about everything in between right there. They both got parentheses because it was less than and greater than, no, or equals to. Interval notation comes from our graph. It's going from -6 to 1, parentheses, because we have parentheses here. And if it needs it as a compound inequality, it always needs to go from least to greatest. So my least is -6 because it's now coming first. We had to flip this symbol to now put our X, and then this one's in the correct order. So sorry, I was kind of all over the place while doing these, but that was your recap. And this kind of shows that anytime that we have less thans, what happens with our graph? We're talking about everything in between these numbers, because these are all of our and statements.